1 is 3, and your m is 0. So you have x minus 1 technically, but you just get y minus 3 equals 0. I mean, you can rewrite it as y equals 3 if you want. Are there any questions?
Do you have to simplify for the final answer? Like, could you leave it in point slope form, or do you have to make it y equals 3?
Um, I feel like it depends. If it wasn't just 0 on the other side, I would just leave it in point slope form. But because it's just 0 on the other side, I just made it y equals 3, but technically it's the same answer, so shouldn't matter.
Okay, thank you.
Yeah.
I'm confused on how you got the fraction, the 20x to the third, like that section.
If
Can you go over that again, please?
Oh, yeah. So let me just kind of clear up
If
some space. So this part right here is from the taking the derivative of the natural log of 5x to the fourth minus 2x minus 2. So the derivative of natural log is 1 over whatever is on the inside. So to just start with that, with chain rule, taking the derivative of the outside, so the natural log. So 1 over whatever is on the inside. And then you multiply with the derivative of the inside. So now that's where you get the 20x cubed minus 2. And then multiplying those together, it's like the same as saying this fraction.
okay, thank you.
Yeah. Okay. So do you guys feel like more confident or more nervous now that you've like gone through some of the questions?
More confident.
I would say definitely more confident. I honestly looked at it before and I did not know what was going on, even when I looked at the solutions.
Okay, perfect. Yeah,
Thank you like so much, like for real.
yeah, no worries. Because I was like looking at homework that I have like the other day, and I was like, I mean, it's due like Tuesday, but it's like Tuesday at midnight, so it's okay. I can afford to do this. Okay. So for problem number 4 is for the function p of x below. Find values of a and b such that p of x is differentiable at x equals -1. Okay, so I did try to ask Professor Eastham about how to answer it, and now that I'm looking at my solution, that's like pretty much it. So to like explain it, so you want p of x, which is p of x equals the piecewise function ax squared minus 4 when x is greater than or equal to 1 on bx plus 2, x is less than -1. So you want p of x to be differentiable at x equals -1. To be differentiable at x equals to -1 means like the derivative exists there. Derivative exists at x equals -1. And because the derivative, if you remember, can be found like defined as like a limit, you're basically saying I want that limit on the left hand and the right hand side to equal each other, which is basically saying, hey, I want my derivative to the left of -1 and to the right of -1 to equal each other. So you want to take like, so your left hand side in this case is technically like this lower piece. So left hand is P of X, or like, okay, so to be clear, your left hand is when it's left of X, or sorry, left of -1. Oh man. Okay, so bx plus 2, and you take the derivative of it. Derivative with respect to x, so this is b. Okay, so we have that. Technically, if you plug -1 in, still is b. So on your right hand, so the right to the right of -1, so this is when like x is greater than or equal to -1, your p of x equals a x squared minus 4. Take the derivative of it, you got 2ax. Okay, so you want left and right derivatives to equal each other when p is like at x equals -1. So you plug in the -1, you get -2a. Cool. What it means to have your left and right ones be equal to each other is literally just that b equals -2a. So, yes. That means that like p of x is differentiable at x equals -1 for values a and b such that like b equals -2a. So that is it for that question. Any questions or concerns for this one?
How do you know which one's like left hand, which one's right hand?
So left hand is just like basically to the left of -1 and to the right of -1. So if you're less than -1, you're on the left of -1. If you're on the right of -1, you're like greater than -1. So it's just arbitrary. You just want like both of them to equal each other. So the step is take the derivative of both pieces and then plug in the point that you want it to be differentiable at, and then set the derivatives equal to each other. Still a bit confused over it.
Got it.
Okay, so a similar example would be here, let me just clear it up. Sometimes I debate whether or not I should get an iPad, but I'm like convinced I can still survive off of my 7-year-old Surface Pro. But you know what? It might be the day soon. So a similar example is, say if you have p of x equals I don't know, like 4ax to the third minus 4x, when x is greater than or equal to 0, and then 7b x cubed when x is less than 0. So I want p to be differentiable at x equals 0. Cool. Now I just take the derivative of both sides. So when x is less than 0, and then when x is greater than or equal to 0. Shit. Oh, I'm so sorry. I missed it. Give me a second. Actually, here, I'll just finish up this example and then I'll go over the question that I was just asked. Let's see here. When x is less than or equal to 0. Okay, so when it is less than or equal to 0, you're using the 7b x squared part. When it is greater than or equal to 0, you're using the 4ax cubed part. You want to take the derivative of both sides. Okay, so this guy is 14bx. Excuse me. And then derivative of this other guy is 12ax squared minus 4. And then you want to plug in to the derivative the point that you want to be differentiable at. So in this case, it's 0. Plug it in, this goes to 0. Plug this guy in, it's -4. So because you can see clearly that 0 does not equal -4, there are no values of a and b for like p to be differentiable at x equals 0. So that is like one example. If you get like, yes?
Oh, sorry. So the other one was differentiable because it was a variable equal to 2a.
Yeah, because it was like -2a equals b. So that's like still differentiable because as long as like a and b are still like there by the end, you can say that like, oh, okay, a and b just have to play together like in this rule, and then it's differentiable at like that spot.
Okay, so they don't
but
have
in
to
this
actually be
case,
equal to each other, right?
yeah, they don't have to be equal to each other. But in this case, because like you don't have an a and you don't have a b anymore, and it's just like two numbers, you know for sure that 0 does not equal -4. So that means that there are no values of a and b for p to be differentiable at like x equals 0.
Well, do both a and b have to be at the end result, or does it just be one of them or something?
There's a chance that maybe like one of them is at the end, but then that would mean that like, oh, it's differentiable for any value of b as long as a is like this certain value. Like, I trust that you all can perfectly interpret that. So, okay, I had a question which was, I'm still a little confused on question number 2. So a similar example to question number 2 is finding the limit, or not the limit, the derivative using the limit definition. So say I have f of x over, let's make this easy for myself, 1 over, let's just do like x plus 1. Okay. So the, give it a second to not freak out. So say I have f of x equals 1 over x plus 1, and I want to find, let's see here, f prime of 1. Okay, so I want to find f prime of 1. That means I need the limit, as the limit definition would be f prime of 1 equals the limit as x approaches a. Oh, my bad. Okay. So there are actually two definitions for the limit. There's this one, where f prime of x equals the limit as h approaches 0 of f of x plus h minus f of x over h. the other one is f prime of a. So your a value in this case is 1, where the limit as x approaches a of f of x minus f of a over x minus a. So these are your two limit definitions. I'll just run through both of them. So say I wanted f prime of 1, so I could just plug 1 in straight up right now. So I have 1h minus f of 1 over h. In fact, I'm just going to pull the h out unless this whole thing crashes. Okay, so I'm going to pull an h out and I'm going to leave it like that. Like waiting for it to load. Oh no. Okay. I wish I had better internet. Gosh dang it. I'd be so much better at Valorant if I had better internet, but I don't. So share screen. Hopefully this doesn't do that again. Just needed to survive to like 8:30 or something. Okay, so all right. I have this, and now I'm gonna plug in the functions themselves. So everywhere I see an x, I put 1 plus h in, so 1 over 1 plus h minus f of 1. That would be 1 over 1 plus 1, also known as 1/2. Okay, so now I just find the common denominator. In this case, it would be 2 times 1 plus h. And then on top, I have 2 minus 1 plus h. Keep in mind your parentheses. And then after that, simplify everything. So this is going to be 2 minus 1 minus h. So I have 1 minus h on top and 2 times 1 plus h on the bottom. Did I do something wrong already? Okay, so 1 plus h. Oh, sorry. So my mistake here is that when I plugged in 1 plus h, it's technically that. Okay, perfect. So right now, on the bottom, I have 1 over 2 plus h minus 1 over 2. Okay, perfect. So, like I said before, common denominator, so 2 minus 2 plus h. Common denominator is 2 times 2 plus h. And then just get everything to work. Okay, so up here, I'm left with negative h. 2 plus h is down here. The h's cancel out, so I'm left with negative 1 up here. So whenever you're canceling out, make sure that your negative doesn't get lost. So negative 1 over 2 times 2 plus h. And if I put in h right now, I get negative 1 over 2 times 2 plus 0. So that's basically negative 1/4. Okay, in theory, I should be getting the same thing over here on this limit. So limit as, in this case, your a is negative 1. Or, sorry, not negative 1, just 1. So 1, 1. Okay. Limit x approaches 1. So f of x is... Okay, first I'm going to pull out the x minus 1. And then I'm left with f of x minus f of 1. And limit as x approaches 1 of 1 over x minus 1. Put in the functions. So 1 over x plus 1 minus 1 over... Oh, no. 1 over... okay, x... My bad, not x. 1 plus 1. 1 plus 1 is 2, so 1/2. Okay, so from here, common denominator. Really, the whole story of how this definition works is it's a lot of common denominator. So, yeah, 2 minus x plus 1. And then you have 2 times x plus 1 down here. Okay. X minus 1. Okay, so up top you have 2 minus x minus 1 when you distribute the negative. So you're left with 1 minus x over 2x plus 1. Okay. I mean, that's pretty close to x minus 1 if you pull out a negative. So if you do little swapsies, you do one of these. You now have an x minus 1 that you can cancel out with this guy. Easy peasy. X, approaches 1, negative 1 on top, 2x plus 1. Plug in 1 now. You couldn't plug in 1 before because that 1 over x minus 1 would have been 1 over 0. You can now because you canceled that. So negative 1 over 2 times 1 plus 1, which is 2 times 2, negative 1/4. Whew. Okay. Any questions? Now's the perfect time to take a picture of this. I'm scared of screenshotting this because I feel like my laptop would just crash. So, okay. Here, I'll just see if I can create a new whiteboard without breaking everything. Let's see, 5. Oh, last question. Okay. Let's see here. So this last question is going to be a question on essentially like understanding position functions and velocity functions. Big thing to remember, the derivative of the position function is your velocity function. So, okay, a clown figurine bounces on top of a spring in a jack-in-the-box. The clown's displacement from equilibrium is given by y equals 12 cosine of 2 over 3t minus 8 sine of 2 over 3t. Okay, so displacement is another word for position. So this is your position. That's the thing that gives you your position. And this is, okay. Let me collect my thoughts for a second. So this is classic mistake people made on the first midterm that cost them like 1 point, which was not including their units. So in this case, excuse me, This is in inches. Please just. Okay. Give me a second. So your position is in inches. If it will let me write. Okay. So your position is given in inches. Inches. And it's your time, t, is given in seconds. Okay. Important to remember for later. It's asking for what the clown's position and velocity is at t equals pi over 8. So your position, is right there, which means you can just plug t straight in right here, right now. So say like 2 cosine of 2 over 3 pi over 8 minus 8 sine 2 over 3 pi over 8. Okay. So simplifying everything down, 2 pi over 24 is pi over 12. Give it a second. It's lagging. Okay. So pi over 12. Please don't break. Okay. Sine of same thing, pi over 12. Perfect. And this is in inches. Yep. So now for your velocity, you need the derivative of y. So the derivative of y is going to be a series of chain rule. So derivative of cosine is negative sine, so negative sine of 2 over 3. Oh, please don't break now. Okay, 2 over 3 t. And derivative of the inside of 2 over 3 t is equal to 2 over 3. So multiply that on. And then derivative of sine is cosine. So 8 stays the same, minus stays the same, cosine comes in, keep the inside the same. Derivative of the inside is once again still 2/3. Okay, so simplifying this all out, you have let's see, your 12 times 2/3 is 8. Yes, -8 sine 2 over 3t minus 16 over 3 cosine 2 over 3. That's not supposed to be a pi. That's supposed to be a t. Okay, t. Now you can finally plug in for time of pi over 8. So you will get 8 sine, same thing of 2/3 times pi over 8. That's still pi over 12 minus 16 over 3 of cosine of pi over 12. That is in velocity is distance over time, so not centimeters, inches over seconds. And that's it. That's the practice midterm.
Why do you
Yes?
why do you multiply by 2/3 for y prime of t?
That is because of chain rule. So remember how you had your outside function and your inside function? Your outside function is sine, your inside function is 2/3 t.
Mhm.
So the derivative of the outside. Oh, sorry. The outside function is cosine. So the derivative of cosine is negative sine. You keep the inside the same, so that's why you wrote negative sine 2/3 t.
Mhm.
And then you take the derivative of the inside, which is 2/3, and multiply it to the thing before. So that's why there's this like extra 2/3 floating outside.
Okay, so it's only when it's like the minus sign of x and minus like cosine.
That minus sign is from the derivative of sine, or my bad, the derivative of cosine being negative sine.
Derivative. Okay.
Yeah.
Okay. Thank you.
Yeah. So yeah, there's like one question from like before. Somebody asked, I think it was like question D of one. So 1D, 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 1D. What was 1D? Okay, to the person who asked me about question 1D, that is basically product rule. So let me see if I can erase this fast enough before something crashes and I cry. Okay, so 1D is 1D, 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 1D. Y of x equals 5e to the x secant of x times 5x to the third minus 4x squared plus 2x plus 1. So the way I did it is because I saw that everything is just multiplied to each other. And 5 is a constant. I just took the 5 out before I took the derivative of anything. You can do it that way, which is how I did it on the midterm solution that was uploaded. Or you can do it this way, where you essentially include the 5 as part of e to the x, and then you only have like these 3 parts that you need to worry about. Both will get you essentially the same answer. You won't lose points one way or another. So here you do product rule. So each part gets a turn having its derivative being taken. So this first part, the derivative of 5e to the x is just 5e to the x. So you have this part, and then the rest of it stays the same. Okay. And then you add the next part. So the second part is the thing that you're now going to be taking the derivative of. So this 5e to the x stays the same. Secant of x times tangent of x is the derivative of secant. And then the 5x to the third bit stays the same. So now it's that third bit's turn to have its derivative taken. So the 5e to the x and secant of x are just like moved down. Now the derivative of this third bit is 15x squared minus 8x plus 2. And that is how you get that. The answer in the solution for the practice midterm, I wrote like 5 all the way on the outside because technically you could pull 5 out on the outside. Really, you could pull out a whole entire 5e to the x secant x to the outside, but you don't need to. It's all the same anyway. You'll still get your points as long as you took the derivative properly. Yes. Are there any like final questions and concerns? My throat is like really giving out.
I'm sorry, think we could go over 1E unless it's over time. I don't want to.
Oh, don't worry, don't worry, don't worry. I had so many technical difficulties, I practically should go over time a little bit. So 1E is, okay, so 1E is k of x equals secant of, okay, so e to the secant of 2x multiplied with 5, oh, sorry, multiplied with e to the 5x minus 9, all over the square root of e to the x. Okay, so give it a little bit so that it doesn't freak out and crash once again. But essentially, you're probably going to use quotient rule for this. I have it done both ways. Let's see. So quotient rule might be the move here if you're not comfortable with simplifying stuff. So you know that the square root of e to the x is e to the 1/2 x, because the square root of something is just like that thing to the 1/2. So your e to the x is the square root of, like, not square root, to like the 1/2. Another way to understand that is I'll be able to write it once I have internet again. Come on, dude. Okay, so e to the x. So that is the same thing as saying e to the x, all to the power of 1/2. And through exponent rules, this is just 1/2 x. If that writes out. Ooh, okay. So now that we have that figured out, there's k prime of x. Let's use quotient rule. So okay, so low d high, high d low. But in your numerator, you want to notice that you basically have a product. So inside of this quotient rule, you have product rule as well. So low is your denominator. So low 1/2 x. D high is the derivative of your numerator. So you got product rule on your hands. So the derivative of the first, so the derivative of secant is secant tangent, but you have chain rule. So the derivative of secant of 2x is secant 2x times tangent 2x, because that's the outside, and then the derivative of the inside, the 2x, is 2, and you can just write that out in the front right there. Okay, derivative of the first times the second, so this e to the x, or e to the 5x minus 9, stays the same. Now we have unstable internet. So now we can add the second part of your product rule. So the first times the derivative of the second. So the first is your secant of 2x times the derivative of the second, that being e to the 5x minus 9. So derivative of e to the x is just itself, and it's chain rule. So the function on the inside is that 5x minus 9. So on the outside, it's e to the whatever. So your derivative of e to the whatever is e to the whatever multiplied by the derivative of the thing on the inside. So derivative of 5x minus 9 is 5. Bam. Easy. And that was just product rule for this first bit. So this was low d high minus high d low. So high is your secant 2x e to the 5x minus 9. Your d low is the derivative of this guy, basically. Oh no. the derivative of e to the 1/2 x, this guy. So the derivative of e to the 1/2 x, well, just like before, derivative of whatever, or like e to the whatever, and then multiply with the derivative of the inside. In this case, it's 1/2. 1/2. Bam. Now you have the numerator of your quotient rule derivative, or the numerator part of your derivative, and then your denominator part is your original denominator, but now squared. So your e to the 1/2 x squared. Yes, and that is the entire answer. Yes. That is if you do it as a quotient rule.
Is it okay if you say one more time why there's a half in front of the derivative of e half like to the x power?
Yeah, so you have e to the 1/2 x, right? That you want to take the derivative of. So your outside function, okay, so first of all, look at this and you're like, okay, I need to do chain rule because it's not just normal e to the x, it's e to the 1/2 x. So your outside function is essentially this e part, and then your inside function is the 1/2 x part. So the derivative of e to the x is just e to the x. So in this case, you're keeping the inside the same. So e to the 1/2 x. You're keeping basically the same thing. And then you're taking the derivative of the inside function, which is 1/2 x, which is going to be 1/2.
Oh, okay, I understand. Thank you.
Yeah. Okay. So, I don't think I can really talk anymore. So, I'm going to correct the error I made on the practice midterm and then re-upload it. And I wish all of you the best of luck. I didn't expect like as many people to come. I only expected like 5 people to show up, but it was like 25, and I was like, oh, dang. But yes, I hope you guys are gonna do well on your midterm. You guys are gonna be fine. So
Thank you, Pepe.